Welcome to my video lecture based on electric machine 2, paper code PCE501. Today's topic, parallel operation of alternator. In my previous lecture, I have already discussed about synchronous machine and alternator operations and how the machine can be synchronized with infinite bus. That also discussed. Armature reaction, two-reaction theory, and MMF method, EMF method of voltage regulation, those parts also have been discussed. Myself, Rubram Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra, Institute of Technology and Sports Complex. Previously, it was known as Dr. Sudhir Chandra, Engineering College. This institute is under JISD. So, let us start with our topic, that is parallel operation of alternator. So, first of all, we have to understand what is the meaning of parallel operation. That means, more than one, that means 2 or 3 number of alternators should be working together with the same state. That is known as parallel operation. That means, more than one number of alternators will be acting together. So definitely when 2, 3, 4, 5, 6 multiple number of alternators are working together, definitely they need to maintain some characteristics or some necessary condition they have to meet. Those two we will discuss here. Now let us start why we will do the parallel operation. So there are 6 points there. And due to those reasons, we are considering parallel operation. So first of all, to supply higher amount of load, when an alternator is connected, suppose a 60 MV alternator is there and the load requirement is 100 MVA. So definitely it is not possible to give that amount of load by using that a single alternator. So we have to connect multiple alternators together. So for supplying higher amount of load, we have to connect several alternators. We need to connect. Secondly, with minimal disturbance in main installation part, furthermore, number of alternators can be connected or removed from supply. Thirdly, during light load, some alternator may shut down. Fourthly, while servicing or maintenance, the service remains continuous. Fifthly, reduce operating cost, and sixthly, ensure better security of supply. That means there are several reasons are there for connecting alternators in parallel. First one, supply higher amount of loads. Then the minimal disturbance is main installation part. Furthermore, no number of alternators can be connected or removed from supply. Suppose there is some problem arises and we want to repair an alternator. Definitely, if multiple alternators are connected, then we can easily remove one alternator from there, and the remaining alternator will share the load. Next, during light load, some alternator may be shut down. Definitely, throughout the day, the amount of load requirement is different. That means, suppose in daytime, we don't need any lights, but AC is on during summer. So definitely at the daytime, the electricity consumption is higher. So definitely the load requirement is high, so we have to connect much more alternators together. But at the night time, all the lights are switched off and TV and other devices are also off. At the time, the load requirement is less. So at that condition, we can remove one alternator or two alternator as per our requirement. Fourthly, while servicing or maintenance, the service remains continuous. Like that, if we have only one alternator is there and that needs to be serviced, definitely the total system will be collapsed. But if it is connected with multiple alternators and one alternator is removed, remaining alternators will work, so service will continue. There will be no disturbance in service. Fifthly, reduce operating cost. Definitely, the total cost will be shared, so the operating cost will be reduced. Ensure greater security of supply. It is easily understandable if multiple alternators are there, the security of supply will be also enhanced. Now, the condition for parallel operation. What are the conditions we need to maintain for parallel operation? First one, same output voltage rating. Secondly, same frequency. And frequency is 120 F by P. Thirdly, KVA rating may be different, but generated waveform should be same. Fourthly, speed load characteristics should be same, and fifthly, reactance should be same. So, what are the things? The operating voltage output voltage rating should be same. Frequency of the alternator should be same. KVA rating may be different, but generated waveform should be same. Fourthly, speed load characteristics should be same, and fifthly, reactance should be same. These are the conditions for operating multiple alternators together. Now, let us consider how the power will be shared by two alternators. Consider two alternators operated in parallel. Okay. Let W1 equals to full load power rating of machine 1. Okay. And W2 is the full load power rating of machine 2. That means the power rating of two machines are different. Now let us, P1 is the amount of power shared by machine 1 and P2 is the amount of power shared by machine 2, that means alternator 2. And P is the total power supplied by the two alternators. Okay. Now, F01 is the no load frequency of alternator 1. F02 is the no load frequency of alternator 2 and FL1 is the full load frequency of alternator 1. FL2 is the full load frequency of alternator 2 and F is the common operating frequency when the two alternators are running in parallel. So this is the load frequency characteristics. This is load and this one is the frequency. And this is the P1, the power shared by alternator 1 and this is P2, power shared by alternator 2. And this is the full load rating and this one is the full load rating of alternator 2. This is the frequency, no load condition and this is the frequency at full load. So those things have been highlighted here. Now, for alternator 1, the drop-in frequency from no load to full load is F01 minus FL1 and drop-in frequency per unit rating is F01 minus FL1 by W1 and drop-in frequency for a load of P1 it will be F01 minus FL1 divided by W1 into P1. Similar way, operating frequency of the alternator 1 will be no load frequency minus drop-in frequency. So the frequency will be F01 minus FL1 divided by W1 into P1. This is the operating frequency of alternator 1. Okay. Now similar way we can calculate for alternator 2, and we are getting that the operating frequency for alternator 2 is F02 minus F02 minus FL2 whole divided by W2 into P2, and from 1 and 2 by comparing it, and we are getting that P1 plus P2 equals to P. From these relations we can easily calculate how much power will be shared by each alternators. Now let us consider one example related to this. Two station generators A and B operating parallel. Station capacity of A is 50 megawatt and B is 25 megawatt. Full load speed regulation of station A is 3% and B is 3.5%. Calculate the load sharing if the connected load is 50 megawatt and no load frequency is 60. So what are the points are given? In generating station A and B operated in parallel. A 50 megawatt, B 25 megawatt. Full load speed regulation of A station is 3% and B is 3.5%. Calculate the load sharing if the connected load is 50 megawatt and no load frequency is 50 Hz. Let P1 is the load taken by generator A in megawatt and P2 is the load taken by generator B in megawatt. So P1 plus P2 equals to 50. So the original frequency as no load, that is F0 equals to 50 Hz. Generator A, we can write for a load of 50 megawatt, the drop in frequency is 3% of F0, that means 3% of 50 Hz. So it will be 1.5 Hz. And for a 1 megawatt, drop in frequency will be 1.5 by 50. And for P megawatt, drop in frequency will be 1.5 by 50 into P1. So the operating frequency for generator A, it will be FA equals to original drop in frequency, that is 50 minus 1.5 by 50 into P1. That is the operating frequency of generator A. Now in case of generator B, that is FB equals to 50 minus 3.5 by 50 into P2. Since for parallel operating, FA equals to FB, so it will be 50 minus 1.5 by 50 into P1 equals to 50 minus 3.5 by 50 into P2. So comparing these two, we are getting that 7 by 3 P2 cos P2 equals to 50. We have put it in place of P1, we have put a 7 by 3 P2. And from there we are getting that P1 equals to 35 megawatt and P2 equals to 15 megawatt. These are the things we have got, that by sharing two alternators, this amount of power will be shared by alternator A and B. So, in this problem we have seen that the alternator A and B has been operated in parallel and their capacity is also given, that is 50 and 25. And taking those points, we have calculated all these values and the operating frequency for generator A and generator B is separately calculated. Then from there we have calculated the sharing value of 35 megawatt and for alternator A and 15 megawatt for alternator weak. That means in this total lecture, what we have seen, that's why the parallel operations are required, the reasons behind the parallel operation. Then we have discussed about the condition for parallel operation. These are the all conditions. These are the not essential conditions. This is combination for essential and necessary conditions. Combination of both. Next, how the power share. That means when alternator, 2 or 3 alternators are connected together and a particular load is given, definitely the alternator will be shared differently according to their power ratings and their full load frequency operation range. With that mentioning that they will operate, and that thing we have shown here. And a numerical problem also given here, and from there we have easily understand that alternator A will share much more power than alternator B. You can see here that alternator A is sharing 35 megawatt and alternator B is sharing 15 megawatt. So comparing these two, you can easily understand the amount of sharing. So now we will highlight the necessary condition for parallel operation. Previously the condition we have seen, that is necessary condition as well as the required conditions. Now we will discuss about the necessary condition. Necessary means without those parameters matching, the alternators cannot operate in parallel. And another thing you have to keep in mind, before connecting the alternators in parallel, we have to test the alternator synchronization. And that thing can be done with the same experiment of light and dark lamp method, where we have connected the alternators in green and we have matched the voltages of terminals and we have matched the frequency of the alternators with the grid frequency with the help of either synchronoscope or by using dark lamp, light lamp method. So let us point out our condition, that is necessary condition for parallel operation. So our first necessary condition is the phase sequence of the busbar voltages and incoming machine voltage should be same. Phase sequence of busbar voltages and incoming machine voltage should be same. Secondly, the busbar voltage and incoming machine terminal voltage must be in phase. That means we have to match the voltage phase sequence of the voltage and also the terminal voltage phase also we have to match. Thirdly, the terminal voltage of the incoming machine should be equal to that of the alternator with which is to be run in parallel or with the busbar voltage. That means the terminal voltage of the incoming machine should be equal to that of the alternator with which is to be run in parallel or with the busbar voltage. Fourthly, the frequency of the generated voltage of the incoming machine must be equal to the frequency of the voltage of the live busbar. So our fourth condition is the frequency of the generated voltage of the incoming machine must be equal to the frequency of the voltage of the live busbar. So these are the things four things necessary condition for parallel operation. So that is all about our parallel operation, and we have to keep in mind that parallel operation of alternator is very important, and before connecting the alternators in parallel, we have to definitely check the synchronization, phase sequence matching, and polarity should be also same. That means we have to match. And after that matching, we can connect the alternators. Otherwise, there will be rushing of current, and which will create a circulation of current in between the parallel alternators, and it will create a breakdown of alternators. So definitely we have to be cautious. You can follow the book of Asta Kushen for alternators, and also can follow the book of Dr. Kokari of electrical machines in this regard. Thank you all. Thank you all for listening my lecture. And in my next lecture, we will again continue about synchronous machine. And not much more for today's class. After that is for parallel operation of alternators. Thank you all for being with me in this lecture, and hope to all of you to look forward in my next lecture. Thank you.